Okay, in the last video we talked about hydrates and how hydrates, according to this video that I had you look at, was the result of a solution that contained the ionic compound, and as the water was evaporated off in a process called recrystallization, that as the water boiled off, the crystals then trapped some of the water before it had a chance to escape. And that trapping did not make it part of the compound, but it did make it part of the complex of the different looking salt than the anhydrous salt, or ionic compound. Ionic compounds and salts, by the way, mean the same thing. Okay, so what we're going to look at today is how we can calculate the percentage of water that is trapped within this. And if we ever get a chance to start doing labs again, I'm not sure that's going to happen, at least in 2021. I think this is going to be the lab that we do first. It's pretty easy to do, but it's pretty, not spectacular, but you can see the results right in front of your eyes happening. And you know when it's definitely getting plugged in first. Okay, well, let's get into the mathematics. Yes, you will need your calculator for this, so if you don't have it, kind of stop it and then follow the math as I go through this when you come back. Okay, so the way we're going to do this, we're going to start off with this hydrate. Barium chloride, decahydrate. Okay, now, barium's not a transition mineral, so we don't need a removal for this. But what we want to find is the total mass of the hydrate. And we're going to make it a molar mass. We want grams per mole. Okay, so you get your periodic charts out, you find that the mass of barium rounded out to 3 significant figures is 137 grams. Plus the mass of chlorine rounded off to 3 sig figs is 35.5 grams, and then we have 2 of them, which is what that 2 means. Now, we get to this dot. So this dot means not multiplication. It's just saying, look, this is trapped inside of it, but it's not really part of the whole complex, so we use a dot for this. Now, dot is also used as multiplication, but that's a different context. In this case, that dot means in addition to, or plus, 10 times. Now, water, we're going to be doing a lot of water work, so we don't need to be writing out the mass of hydrogen times 2 and the mass of oxygen. Just remember that the total mass of water is 18.0 grams. When we calculate all this together, we get an answer of 388 grams. Then we're going to be asked to find what percentage of the crystal has trapped water. So we're going to look for the percentage of water based upon this. Well, the water part is the 10 times 18.0, so I'll put that on top. Divided by the entire mass, which is 388 grams. And then we change that to a percent by multiplying by 100. Okay? And we get for this 46.4%. So 46.4% of that hydrate is trapped water. Let's do one more to make sure we got this down, and then we'll go ahead and give you your practice problems. This one involves a transition metal that we call tungsten 4 sulfate. And this is a dihydrate. So I, of course, want to write the word di, because that's how awake I am right now. Good job, me. Now, same thing. We go to the periodic chart and find the mass of tungsten, which is 184 grams. And we're going to do exactly everything as it's written out right here. So we've got a parenthesis here. Sulfur, right off the 3 sig figs, is 32.1 grams. plus oxygen, which is 16.0 grams. And we got 4 of them, so we put times 4. And then that whole parenthesis here then is double. Plus, and that's what the dot means, plus 2 watts. So 2 times 18.0 grams. We add all that together and we get 412 grams. Okay, now we want to find the percentage of water out of that hydrate. So the percentage of water is based on 2 times 18.0 grams divided by the total mass of 412 grams times 100. Round off your answer to 3 sig figs, 8.74%. And that is how you find percentage of water in hydrates. For practice problems, we have 4 hydrates. Find the mass of the hydrate, and I should say molar mass of the hydrate like I did, and then percentage of water in those hydrates. Have fun.